Hey everybody, Mr. Stewart here. Here is the screencast that follows our lesson today about the primary trigonometric ratios. So recall we learned about the definitions of sine, cosine, and the tangent ratios. So your goal at this point in time is to solve for missing side lengths and angles in right triangles. So let's give that a go with a few examples. Okay, so here's example one. So let's solve this triangle. And when you see the word solve, okay, in reference to triangles, you'll want to jot this down. That means to find everything. So if you're missing a side or two sides or more, find all of them. If you're missing angles, find them all. Okay, so I'm recognizing that here, this has been whited out a bit, so I'm just going to put that in. So let's start with, well, we can start anywhere, sides or angles. I think for the time being, I'm going to focus on this angle here. Okay, if you haven't seen that before, okay, that is a Greek letter. That symbol represents the letter theta. Okay, so that's how it's said, theta. It simply represents an angle. So I can see that we have some information already. Right? We're aware that that's there. We've got the 18. So we could use the sum of the angles theorem in order to solve for the missing angle. Okay, so theta in this case would be two ways to look at it. We could do 180 minus the sum of the angles we have. Okay. Okay. Or we could simply focus on using the 90. We already know that we have 90 degrees. So what's left over in total would have to be 90. And as you do the math here, okay, if you were to focus on, I'm going to do this a little bit differently because it's always good to review skills in different contexts. You might remember that when you have a set of brackets, okay, that negative has an impact on the sign of the numbers inside. In fact, it makes it the opposite. Okay, so when we distribute the negative over each of these values, okay, those values become negative themselves. So we can remove the parentheses and you can see how the sign changes. So theta then would be 90 minus 18, or otherwise, what we have here, 72 degrees. Okay, so that's the value of theta. It's 72 degrees. Okay. Moving forward, we now have to focus on solving for A and for B. So I'm just going to grab a different color here. Let's start with side, I guess it doesn't really matter. Let's go with B. Okay. So what we want to do here is we would like to use either sine, cosine, or tangent. Okay. So as you can see, B happens to be across from 72. So that tells me that B is the opposite side length. We don't know A, but we do have this side over here, which is the 9. That's going to be the adjacent side to theta, okay, to that angle here. So being that that's what we have, remember that we dealt with opposite over hypotenuse, adjacent over hypotenuse, and then we had opposite over the adjacent. Okay, so if you take a look at what we have opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And that's what we have here. We have the opposite side and the adjacent. Okay, and we also know that this one is the sine, cosine, and the tangent. Okay, so if we look at this and spell this out, okay, there's a memory device which is commonly used when working with the primary trig ratios. Okay, and it's none other than so ka toa. Okay, so just a memory device to help you remember the order of the sides and what ratio, sine, cosine, or tangent, that you need to choose. So because we have opposite and we have adjacent, we need to use the tangent ratio. So we're going to write down that the tangent, go over here to give myself space, of 72 degrees is the length of B opposite over adjacent. Okay. And to solve, okay, here we're dividing the answer by 9. So to isolate B, we must multiply by 9. Okay, and what we do to one side, we do to the other. Okay, notice that I've used a multiplication symbol here. Okay, it's perfectly fine to write 9 tan 72 as it's understood that we are multiplying there. And here we end up with B. So now it boils down to a calculator problem. So let's get the scientific calculator out and see what we can come up with. Okay, so on your calculator, make sure that you are in degree mode. Okay, and you can see that, oops, sorry, you can see that, let's get that calculator back here. There we go. That mine is in degree mode. It's been selected here. This is radians. That's a different measurement for grade 11 and 12, but here's degrees. So for me, what I'm going to do, my calculator functions this way. I need to take the angle and then press tan. So the ratio is basically 3 to 1. So 3.07. That's about 3 to 1. So the adjacent side, sorry, the opposite side should be 3 times longer than the adjacent. Okay. So now that I've pressed that, I'm going to multiply by the 9. And although it's not indicated to how we're going to round, the values in the question are whole numbers themselves, so no decimal points. So I think I'll round this up to 28. So 28 centimeters is about the length of B. Okay. Last but not least, we need to deal with side A. Okay. So you've got options here. Okay, you've got different ways that you can do this. I'm going to focus on the trig method using a ratio, but recall, I'm just going to go over here in the margin. Recall that when you have 3 sides of a triangle and you're looking for the length of the hypotenuse, well, you know what to do. But let's focus on trig. Let's put that away. I don't think we'll need that right now. Okay. Oops, what happened there? I lost my page. There we go. And we'll just get rid of that for now. All right, good enough. So let's focus on the other side. Let's deal with A. Okay, and this time let's use, you know what? It's often good to use information that you have been given already. Okay, especially if you're dealing with a lot of decimals. So because I'm given the 9, that becomes the opposite to 18, and A is the hypotenuse. Okay, so what I'm going to do here is I'm going to find the sine of 18 because sine is opposite over the hypotenuse. And those are the sides I need to deal with. So that's going to be equal to 9, which is opposite, divided by the length of the hypotenuse, which is A. It's the same thing. You notice that the variable is in the denominator and we're dividing by it. That's not a good thing. So we'll multiply that through, okay, in order to cancel it on the right-hand side. Okay? And to cancel simply means to divide one into the other. In fact, I'm sometimes asked, why does that work or how does that function? Well, we could rewrite this as well. You could rewrite it as two separate fractions. Okay? 9 over 1 times a over a gives you the same thing as 9 over a times a. You can test that out with some numbers. So that allows you to divide a into a, and it reduces to 1 over 1. Okay, so that's kind of the reason behind why that works out. And here we have a sine 18 degrees. So I'm just going to tidy this line up a little bit. A sine 18, that's a bit messy. Let's change that. 18 is equal to 9. Okay. So in solving, isolate the a. Okay, so because this here is being multiplied, a times sine 18, and sine 18 is a number. Okay, I'm just gonna, you don't have to bracket it, but I'm just trying to bring emphasis to that. Sine 18 is a number, right? It's a ratio of sides. So when you key that in to the calculator, you get a decimal value. Okay, so please perceive that as a value, as a number. So we can divide by it. And what you do to one side, we'll do to the other. And recall that through division, this reduces to 1 over 1. Okay, so therefore, a is equal to 9 over sine 18. So it'll help from our calculator. Let's see what happens here. Okay. So let's take 9. I'm going to divide that by, I'm going to use some parentheses here just to make sure that the order of operations is going to work. So let's put in 18, and I'll take the sine of that. And then I'll multiply that by, oops, sorry, I don't need to multiply that. I just figured that out. If I close bracket and hit equals, I get about 29. And that's in centimeters. And that makes sense too, right? If you look at your diagram, it is the length of the hypotenuse. So 29 makes for a good answer. So let's check our time on our recording here. It does take a long time to set these examples up, but once you've got it, things do move a lot more quickly. We're up to 13 minutes here, seemingly. So I think we're going to try to max out at 15 and possibly cast either a second video or leave the rest for class. So let's check this one out. Here's a big difference. Okay. This one here, we are going to go for the missing angle. Okay, this is different. We dealt with sides. You can use this stuff for angles too. Well, let's give it a go. So determine the measure of angle A, this one right here, to the nearest degree. Well, it starts out the same way. Let's do some labeling. This is your opposite. This happens to be our adjacent. So as per the acronym SOHCAHTOA, again, it looks like we're dealing with TOA, which is the tangent. That's a poor color. Let's remove that. Get rid of that. Looks like I've changed the script on that. Okay, there we go. So it is this one here, TOA, tangent. So let's set up a ratio. We're going to call that the tan of the unknown angle A is equal to opposite, which is 4 over 8. Okay. And here you can see that's a very nice fraction. When you have an opportunity, sometimes it's nice to work with values in lowest terms. Okay, tan A is a half. I typically wouldn't go to a decimal, especially if the fraction is kind of nasty in that it's a repeating decimal and or it's non-terminating. Okay, so resist the urge to go to the decimal. Sometimes it's okay, right? This one here is a very decent decimal, 0.5. But to get from tan of A to angle A, there must be something that we can do. Okay, well, there is a particular function, okay, that you'll learn about in grade 11 called an inverse function, okay, which more or less undoes what one function does. So instead of using the tangent key on your calculator, we're going to use the inverse keys. So I'm just going to press the inverse. Yours might be the second function. And notice how you have, please disregard the output on the calculator, but you've got sine to the minus 1, cos to the minus 1, and tan to the minus 1. We usually don't say minus 1. We simply call them inverse sine, inverse cosine, and inverse tangent. So this will undo, okay, let me clear this. This will undo the impact of sine, cos, and tan. Okay, so let's enter in point 5, and I'm going to invert the tangent, and it tells me in degrees 26.56, and rounding up to the nearest degree, it's 26 degrees. Okay, so that really is the only difference, okay, that you have to take note of. And in fact, it probably makes some sense to put that step in. Okay, A is precisely the inverse tangent of 0.5. So therefore A is about, let's see, what did we say? 26, 27 degrees. 27 degrees. Okay, so we're probably hitting a 15-minute mark. Oh boy, we're getting further along here, almost 17. Okay, let's go quick here. This one, we'll set it up and we'll have you try it out for yourselves and bring it back into class. Okay, and we'll use that as a learning problem within our groups. But there are two terms I need to help define, and or you could look them up online. Okay, so there are these things called angles of elevation and angles of depression. Okay, so we won't solve this question, but what we will do is we will sketch what these look like. Okay, so an angle of elevation simply means that if you are at ground level, okay, for instance, I'll just say this is the ground, okay, and you're looking up to the top of a building, the top of a tree, anything, okay, I'll just put in some little building over here, okay, the side of a building. The angle that's formed with the ground to the top, this angle, okay, is the angle, right in here, is the angle of elevation. Okay, that's what that is. In other problems, you might see something called an angle of depression. Okay, and in this case, instead of to look up, it means to look down or to look down upon. So the way we do it is we kind of flip this triangle over here. Okay, we kind of take that. Let's see if I can twist that around. I'd have to group all the items together. Probably quicker just to sketch it. So let's say that this is some fictional thing, like it's our line of sight. Sometimes it's called the horizon, right? So if we were standing atop of a cliff, peering out over some beautiful scene, okay, and you look straight out, looking at the horizon, you know, I can see the sun setting over here, how beautiful it is. That we call the horizon or a line of sight. Then if you have an object, say down here, the angle of depression, okay, is here. Okay, give it a name, call it theta, call it alpha, whatever. That is the angle of depression. And sometimes one way to remember it too is that if you form a right triangle as such, the angle of depression is always on the outside, okay, of the triangle. So this area here, the angle is on the outside as opposed to being inside. Okay, so just some little tricks, things to remember. So hopefully you've enjoyed the video. Take a look at some studying this weekend for your quiz on Monday with similar triangles and the Pythagorean theorem. And then we'll do some problem solving as far as this trig sine, cosine, tan is concerned.